Hi, everybody. So this is our last new topic of Chapter 8. So this problem, we're going to do 3 examples of how to find polynomials given the roots. So we're doing the opposite. So imagine where if we were given a polynomial x squared minus 4 equals 0, and we wanted to solve for roots. Roots is the same as x-intercepts. We'd add 4. We'd square root both sides, and then we'd get x equals positive 2 and x equals negative 2. Well, we're doing the opposite now. I'm giving you the roots, and you're going to find this part. So it's actually pretty straightforward. So you're going to do the opposite of this. We're going to write them as factors. So let's go ahead and do that. So we are given 2 roots, x equals 3 and x equals negative 2/3. So what we want to do is write them as parentheses. So imagine how they would go in these parentheses in order to solve to make them like this. Some of you can probably think about it. I'm going to go ahead and write it like this. X equals 3, so we subtract it to the other side. So that's what goes in the parentheses, x minus 3. You could have probably thought of that because in order to solve it to get 3, you'd have to have a minus 3 in here. And in order for it to solve to be this, think about what would have to be written in this parenthesis. So we could think about it like this, x equals negative 2/3. Let's multiply by 3. 3x equals negative 2. Let's add 2. 3x plus 2 equals 0. Does that look correct? Subtract 2, divide by 3, you'd get that. Yes. So that's what goes in the other parenthesis. And actually, this is a polynomial in factored form. And that's good enough if they asked you for it in factored form. This is a quadratic in factored form. It's a quadratic x squared in factored form. What if they wanted you to now write it in, so this is in factored form, what if they wanted you to write it in standard form? Well, if the multiple choice answer was in standard form, you'd go ahead and FOIL this through. So x times 3, 3x squared, x times 2, 2x, 3x times negative 3, negative 9x, and negative 3 times 2, negative 6. So the final answer would be 3x squared minus 7x minus 6 equals y. I'm going to write it as a polynomial. So if we were to graph this in Desmos, I would get a quadratic, a parabola facing up that crosses through those 2 intercepts. Let's try another one where it's not as obvious. Like this was a pretty straightforward example. Let's try another one that's a little bit more tricky. So example 2, go ahead and write it down. Well, I try to erase the screen. Okay, so this time x equals plus or minus square root of 5. So really, it does kind of work the same way. We got to think about how can we get parentheses from here. Well, think about that first example I did. Remember when I did x squared minus 4 equals 0, and then we add 4, and then we square root both sides? Well, it's kind of like saying that, only the square root of 4 is the square root of 5, and so it's not, you can't take the square root of 5. So actually, this one's also pretty easy. We're going to square both sides, essentially. So we're going to go ahead and square this side and square this side. When we square x squared, we get x squared. When we square this, what happens to a positive squared? A positive squared is still a positive. What happens to a negative squared? A negative squared is also a positive. So sometimes students say, well, what happens to this positive and negative? Well, positive squared is positive, negative squared is also positive. So it's just a positive. And what happens to a square root when you square it? They cancel. Okay, so we're going to move 5 to the other side by subtracting it to the other side. So x squared minus 5 equals 0, and that's our answer. Instead of writing it equal to 0, we're going to write it equal to y. This is standard form. We never wrote it in factored form because they're not perfect factors. You can't factor this. This would just be the answer. Let's try one more example that is with imaginary numbers and not a quadratic. Both of the examples we've done so far, there have been 2 roots making it a quadratic. This example, there was 2 roots making it a quadratic. Well, what about one where it's not 2 roots? Okay, so example 3, x equals plus or minus 2i and x equals negative 3. Okay, so how do I know what this is going to be? Is it going to be a quadratic, a cubic, a quintic, a quartic? Well, I have 1, 2 roots and a third root. I have 3 roots. 1, 2, 3. Just to be one more obvious, positive 2i and negative 2i and negative 3 are all 3 roots. Now, these are imaginary roots, so it's a cubic, but only one, it would only cross the axis one time. So like it might be down here. The axis might be down here, and it would cross right here at negative 3, I guess. That would be over here, and then this would not hit the bottom because it would be imaginary. So it would be like this, only this should be moved over to the negative side. Okay, so let's go ahead and solve this. How would we solve this? Well, the same way. This one's probably easy. You can probably do it in your head. What needs to go in this parenthesis to make the intercept negative 3 a positive 3? X plus 3 needs to go in the parentheses, because then you solve and you get negative 3. Over here, let's do the same thing we did on the last problem. We're going to set it up like the last problem where we, I guess I erased it. We set it equal to x. So let's go ahead and try that. X equals positive negative 2i. Okay, let's square everything we see. Because don't forget, this is a square root under there. So I'm going to square this side and I'm going to square this side. This will give me x squared. Positive squared is positive. Negative, well, let's do this. Positive 2 squared is 4. Negative 2 squared is still a positive 4. I squared is I squared. Okay, let me repeat that. Positive 2 squared is 4. Negative 2 squared is also a 4. So I just wrote the 4 once. I squared is I squared. Now, what does I squared always become? It always becomes a negative 1, which makes this entire side a negative 4. So x squared equals negative 4. Move it over to the other side. X squared minus 4 is the other factor. So we have just found one factor of x squared minus 4 and the other factor of x plus 3 equals y. That's factored form. What if they wanted you to do it in standard form? So you find the multiple choice answer that looks like this. Actually, this won't be on the final because it's the last lecture and we don't feel like we were going to have enough practice on it, but I didn't want to tell you that till the end in case you stop watching the video. Okay, so now we're going to go ahead and multiply this. X times x squared is x cubed, and then x times negative 4 is negative 4x. 3 times x squared is positive 3x squared, and 3 times negative 4, I made a mistake. So this should have been a positive 4 when I moved it to the other side. So right now, let me correct my mistake. See how it was negative 4 over here? I'm going to move it over to be a positive 4. I forgot to move it over and make it a positive 4, which makes this a positive 4. X squared times x, x cubed. Positive 4 times x, positive 4x. 3 times x squared, 3x squared. 3 times 4, 12. Okay, that's my final answer. Let me rewrite it in standard form. X cubed, then the q squared, then the 4x, then the 12. Okay, so like I mentioned, no, this is not going to be on the final because it's unfair because it was the last lecture and we don't have an assignment and we're not practicing anything with it. But it is important to understand that given the roots, you could still come up with the equation because I do want you to have seen it at least for math analysis. Okay, so I will see you guys again Monday or Tuesday where we do the final, we begin our final exam review. I am going to post over the weekend the review packet and you can print it ahead of time or at least look at it. That way you're ready for the review session. Have a wonderful weekend.